Okay, everybody, we will get started today. I know some of your classmates had trouble getting here, but glad to see we have enough good swimmers to fill the house for the most part. So what we're going to start with today is just going over the syllabus. This is my third time teaching this course, and one thing I've learned is that students don't read the syllabus, so I'll give you all the important things here. But I still encourage you to read the entire document. It has a lot of important information, and really all the important information you will need for this course. Okay, so here's some of the important syllabus items. So the prerequisites for this course are Math 1330, which is pre-calc, and the PA test. Now I don't enforce the math prerequisite. That's really between you and your advisor. I have no idea which math courses you've taken, so I get a lot of questions about that. So as long as, in my mind, as long as you pass the PA test, your math ability is perfectly fine for this course. But that is the one requirement that is sort of inflexible, this PA test that many of you have already taken. It's a department rule. I don't particularly like having to do this in the beginning of the semester. It kind of ruins the first couple weeks of the semester, but it's a requirement, and I can't really make any exceptions on it or I'll lose my job. So that's the story. All right, the textbook for this course, this is sort of what it looks like, although if you get the UH edition, it probably doesn't have a cover on it, but it's Zoomdale and Zoomdale, and it's called Adams' First Approach. So we'll get into a little bit what Adams' First Approach means exactly. The textbook is not 100% required. Most students find it to be a very good resource to help them study, and it is the same textbook that you would use in Chem 1332 if you take that course. So it's only one book for the two classes, but like I said, you do not absolutely have to have it. There's no required assignments that will come from the textbook, and I will try my best to make sure that any of the the tables that you need to learn with different information in it, that you'll have those in the notes when they're there. But it certainly is recommended to get the textbook, and really any edition of this textbook, whether you get it from the bookstore or online, should be fine. There's not a huge difference. There's only, I think, 2 editions of this book anyway, so there's not likely to be many things different between the first 2 editions. Calculators for this course, if you haven't taken the PA test, this is important, but it will be important for all of you for the rest of the semester. You're only allowed to use non-programmable calculators, so that means no graphing calculators. That will be enforced by CASA, so they'll definitely check that when you go in there. And this is a very common one that people use, but any style of scientific calculator is fine as long as it doesn't have graphing capabilities. All right, the grading for this course is very straightforward. A lot of people think it's difficult, but it's right out here for you exactly what you need to do. So there will be 3 midterm exams that are 20 questions, 20 points each. That's going to be a total for 60 points out of the 100 for this course. So the nice thing is, if you want to think about it this way, each exam question is worth 1% of your grade. And that's also true on the final exam, which is not quite twice as long as the midterms. It's going to be 34 questions and then worth 34% of your grade. So 94% of your grade comes from exams. That's fairly harsh, I'm not going to lie. But again, that's set by the department, not by me. So don't blame the messenger. And then the homework is going to be worth 6% or 6 points out of your 100 for the whole course. So the homework, the way that works, I'll have more details about that in a second, but we average together your homework scores and scale it down to 6 points. So it's not that each homework question will also be worth 1%. Each homework question is worth 0.0 something percent. It's really small because there's a lot of homework questions throughout the semester that we average together. And then finally, there are going to be in-class bonus opportunities. More details on those forthcoming, but that can be worth up to 2 points. So in reality, the maximum grade in this score is 102 out of 100. Okay. And then here's the scale, and we won't change this, so don't ask if we're going to curve or anything. This is the curve. I think it's nice to have first day of class. This is your grading scale. Shoot for it. Get the grade that you get. And if everybody in this room gets above a 90, everybody gets an A, right? So there's no competition between you guys, right? You just do your best. So here's what it is. A is 90 and above. A minus 85 to 89, and so on. So there's roughly 3 or 4 points separating each grade level. It is slightly easier than the standard UH scale, I believe. But this is what we've been using for a long time, at least as long as I've been here, probably longer. And so we're not likely to change this anytime soon. So this is going to be the grading scale that we will use for this semester, and it will apply both today and the last day of the semester. Okay, so those are some of the things about grading. More information about the homework. This is going to be sort of your weekly task that you have to fulfill every single week. The homework will be done on Blackboard, just like all the exams will as well. So every homework assignment is going to cover roughly 1 to 2 weeks of material. So you'll see on the syllabus, assuming you choose to take the time to read that, as I suggested, the syllabus is broken down week to week, which sections of the book we're going to cover, and then which sections, and then the homework that's for that week will usually cover the previous week's material, so it'll be offset by a little bit, so you obviously have time to learn everything, and I will do my best to not fall behind. There are going to be, I believe, 12 homework assignments, so roughly 1 per week. Like I said, there's not one this very first week because of the PA test, and then there won't be one, or there won't be an extra one during spring break. There'll be one just for that entire 2 weeks. So it's going to be 12 in total, and we're going to drop your 2 lowest. So we're going to take your 10 highest homework scores and then average them together and scale it down to 6% of your grade. So that said, you can miss or blow off 2 homework assignments and it won't hurt your grade, although I don't necessarily recommend that because the homework assignments are probably your best resource for learning the material every week and staying up to date on what we're doing in class. Each assignment is 12 questions, and the questions range in complexity, obviously, depending on the topic we're covering. And for each assignment, you're going to get 4 attempts maximum, and we count your highest grade of those 4 attempts. So there's really no harm to doing the homework 4 times. It gives you extra practice, gives you a chance to look at more questions that that are going to be very similar to the exam questions. And like I said, we only count your highest score. So even if you get a perfect score on your first attempt, it doesn't hurt you to do more. And it's some of the best students that I've had in this course are the ones that do the homework 4 times every week, because they're the ones that are putting that weekly effort in and really making a strong concerted effort to understand the material every single week and not just waiting until exam time to try to cram it all in. So we give you 4 attempts for those each week, and I encourage you to use them. Now the part that sometimes causes confusion is, because especially since most people wait until the last day to do the homework assignment, is on Sunday there's always going to be 2 homework assignments that are actually available on Blackboard, because the one for that's due the previous week is going to become available first thing in the morning Sunday at midnight, and then the one that's current is not going to be due until the end of the day Sunday. So on Sunday there's going to be 2 assignments available. Make sure you do the right one. It's going to be the one with the smaller chapter number, or check the syllabus if you're unsure. But I've had students before that do the next homework assignment before it's due and forget to do the one that is due, and just watch out for that, okay? So there'll always be 2 assignments available on Sunday, and you'll have exactly one week, or a little bit more than 1 week actually, to do each one. The other thing we do to help you out in preparation for the exam, or to catch up on things you're unsure about, is after each homework assignment is due, we're going to open it back up for you, and you can do 3 more attempts just for practice. They don't count towards your grade, but it allows you to, especially is probably good around exam time, to revisit some of the questions and try them again, make sure you still understand them. So we'll give you 3 practice attempts. They don't count for your grade, but it's something that's recommended that you do if you want to learn the material a little bit better. Now the other important piece of information is about the exams. You'll get a little bit of a flavor for this when you take the PA exam, how the exams work in this course. But they're all going to be taken in CASA, and you're going to use Blackboard for that. Now the important point is that we set the IP address in Blackboard to only allow you to open it in CASA. So if you try to do the exam on your own, it won't work. I think there's a line in the syllabus that if we catch you doing that, we're going to throw you in prison or something. I don't look that closely. So I know people sometimes accidentally click the link. It's okay. It's not going to let you in unless you're an expert level computer hacker. So, but don't even attempt to open the exam outside of CASA. That's really the bottom line, and that's where you're going to take all of them. So like you did for the PA, you'll have to sign up for a time in advance. Usually the exam times open up about 2 weeks before the actual exam, maybe 1 week, something like that. We'll let you know, and you sign up for a time and go there and take it. Each midterm exam is 20 questions, as I mentioned, and you'll have a 75-minute time limit. So you're looking at 3.5 to 4 minutes per question, which usually is plenty of time. We don't typically have students struggling because of the time aspect. And then the final exam is a little bit quicker pace. It's 34 questions, and you'll have a 100-minute time limit, so really close to 3 minutes per question. The questions, and you're going to get a flavor for them by doing the homework. They're really not all that different than the homework questions. They're going to be a combination of multiple choice and type and answer. It's on a computer, so there's only so much we can really give you guys to do. Obviously you can't, we can't have you write essays in Blackboard, and I certainly don't want to grade 500 essays anyway. So you're just going to have mostly multiple choice questions, but some where you'll type in a number or type in a word, that's a very short, straightforward answer. As I said, you're allowed to use a scientific calculator, and you'll always be provided with a periodic table and a list of physical constants. It's the one that's posted in Blackboard in one of those folders, miscellaneous information or whatever it's called. So it's there if you want to take a look at it and get used to using it and the information that's on it. It'll be the same one you get for every single exam. We don't update that document at all. My goal, which I failed on a little bit last spring, but will certainly do better this time, is to finish all the exam material 1 to 2 weeks in advance in class. So that way you'll have enough time to prepare and review for the exam. Although, as I mentioned, your best bet for success is to be doing that consistently every single week, but you'll still have a week or two between when I finish the exam material and when you actually take the exam. Because it's taken in Blackboard, you will see your score right away, so you may or may not like that aspect of taking computerized tests. Depends on your personality, I suppose. But you won't be able to see the full results and review the questions that you missed until after everyone has taken the exam. Obviously, we don't want to be giving away the correct answers before everyone has taken it. So sometime after the exam closes, which is, I think the exam usually starts on Monday and then closes on Thursday for everybody. So sometime on Thursday, you'll be able to review the results. And this is true for both homework assignments and exams, so I should clarify this. I don't mind if you request a regrade or clarification on some answer, but please, you have to do that within 1 week of the homework assignment or the exam. Okay, so sometimes there are problems that are set up poorly on Blackboard, or you typed in a word that was spelled wrong by one letter, but it was very clear you had the right answers. Things like that happen once in a while, so don't be afraid to let me know about that or ask me to take a look at it. But it has to be done within a week of the exam. I don't want, the last week of the semester, I have people asking me, well, can you look at my old homework assignments, see if I can get one more point? It's just, I'm not going to go back in time, 15 weeks to do that. So within a week, please do that. All right. And then more about the bonus quizzes. So this is going to be something that is a little bit new this time around. So last spring, if anybody talked to people from the course last spring, or maybe some of you were in the course last spring, we used what was called Top Hat. It was suggested to me by a colleague. I didn't particularly like it. The students didn't particularly like it. So based on some suggestions that I got on the student reviews, so believe it or not, I do read those, the course reviews that you did at the end, we're going to be using the regular clickers this time, which it looks like, from what I can tell, at least half of you already have and are already set up with, so you don't have to do anything. If you had the clicker last semester for the fall 2016 semester and you already set it up and everything, you don't need to do anything. You're already all ready to go. If you don't have one, again, this is only required for the bonus quizzes. So we will do some clicker questions in class just to, for fun, to keep you engaged, and the students that participate in those, it's a very helpful strategy to really get the most out of these lectures. But like I said, you don't absolutely have to have a clicker unless you want the bonus points. So you can still get 100% in this course without the clicker. That's the bottom line there. I'm a little bit new to this, so I'm not the best source of technical information. So if you have questions about setting up the clicker, there's an email address here, clicker@uh.edu, and there's also a website, I think it's uh.edu/clicker, that has all the information about obtaining and activating your clicker. And the bottom line is, when you go through the activation process, which involves buying the clicker and then logging into the website, there's a link in Blackboard that you can do that. You only have to do it once. You don't have to do it for every single course. And once you get to the website, if you have these 3 check marks on your account, which tells you that you have an active license, a clicker that works, and that you're linked to Blackboard, then you're all ready to go. Okay, that's how you want to check that. The process is very easy. I just went through the training last week, so I'm sure you all are smart enough to figure it out if I can. But again, if you have any questions, the best source of information is going to be clicker@uh.edu, which is the instructional design office. They're very good, very helpful. So that's how the bonus quizzes are going to work. And like I said, they're going to be done through clickers, so I don't have to collect and grade 500 paper quizzes. But like I said, some of the questions will count for your bonus, some of them won't. I'll make it very clear which ones are which, so you don't have to sit there and wonder if this particular question counts or not. When there's a bonus quiz, I'll put up a bunch of flashing lights and sirens to tell you that there's a bonus quiz, so you'll be ready. And those are going to be, so some of those we'll probably do about 6 or so throughout the semester. Those will count towards your 2 bonus points. And the way that the bonus quizzes are graded, which I don't have on here but is important, is if you show up to class and even try to answer the quiz, whether it's right or wrong, you'll get 1 out of 2 points on that particular quiz, and then if you get it right, you get 2 out of 2. So you do get half the points just for participation. So if you attempt every single quiz, you'll get 1 bonus point added to your grade at the end, no matter how you do on those quizzes. And then if you get every single one right, you'll get 2, and then the most likely scenarios will be somewhere in between 1 and 2 for your final bonus score. All right, so there is an advantage just to being here. All right, and then I think the last thing I have, a couple about the syllabus, are just some info specific to this section. So there are 2 sections of Chem 1331 this semester, but we do try to coordinate them as best as we can in terms of the content, and of course the exams and the homework assignments are all the same. But things that are relevant to this one only, my office is in Circ 5023, so that's very easy to get to because we're right here, and you just walk under the little underpass into the next building over, which is Circ. So right out the front door of this building. And then I'm up on the 5th floor. Usually at least one of the elevators works, but they are slow, so sorry about that. I deal with it every day. Office hours, I used to do a poll for office hours, and then I realized that the vast majority of students that answered the poll didn't come to office hours anyway, so I thought that was kind of lame. So I just set them at a time that seemed to work well for a lot of people last year. I assume the representation is the same. Now the deal with office hours is that, these are the times, Monday, Wednesday, and Friday at 11, right before class, Tuesday and Thursday at noon during the same time that we would be having class. Those are the times where I guarantee you I'll be in my office, unless I tell you otherwise. I mean, there might be occasionally I'll have to cancel it, but not often. I'll be there, and if you're able to come, that's a good time to come and ask questions, because I'll be there, and that way we can get as many of you in there as possible. That said, I realize that these times are not going to work for everybody, so you're more than welcome to just come to my office and hope that I'm there, which will usually be true. Or if you really want to be certain, you can send me an email ahead of time and set up an appointment, and I'll be glad to meet with you whenever we can find a convenient time to meet. So these are not the only times that I'll be in my office, but that's the time that I would prefer you come if you're able to. And then also, if you have, a more private matter you want to talk about, something like your grade, obviously you don't want other students there sort of, gawking around, then that's a good time to also set up an appointment to meet instead of just coming during the office hours when there may be several other people there. So those are the regular office hour times. Like I said, I'm very flexible and want to make myself available to you as much as possible outside of those times as well. Email is the best way to get in contact with me. So that's my email address. I typically respond within a few hours, maybe 24 hours at the worst. So that's the best way. I'll give you my office phone number, but there's, like I said, no guarantee I'll actually be there to answer it all the time. But if you need to, you can call that for whatever reason. And then other things that are important about this section, we do have a YouTube channel that I set up. There's the link, and I'll have this on Blackboard if it's not already there. So what I'm going to do this time around, and we're already starting this right now, assuming it's still working. I should probably check on it real quick. Okay, we're still recording. Good. All right, I'm going to record every single lecture. That was another comment that I got last year. Oh, you should record all the lectures. So I said, okay, sure, let's give it a shot. So all of the lectures will be posted to YouTube. I realize that disincentivizes you from coming to class, but we still have those 2 bonus points to dangle in front of you to, hopefully get you to come to class still and enjoy it as part of the live studio audience. But if you miss a class, or you want to review something, those will be available for you on YouTube. I'll try to put them up every afternoon after class when possible. All right, and then we'll also do homework reviews. So one thing I started last year, which seemed to work pretty well, was every week after you guys finish the homework assignment, I'll look at the results and figure out which questions you had the most problems with, and I'll do, just in my office on my own, a little review of those questions. That'll usually be 20 or 30 minutes or so, just however many questions I thought we needed to go over. And then I'll post that to YouTube once a week, so you can go through those and see. They very well could be questions you had trouble with, or just questions that your classmates in general struggle with, and I'll go through that. And then the exam reviews will also be recorded. I'll have more details about the exam reviews later on. I'll try to have them Friday afternoon, although I have another course I'm involved with Friday afternoon this semester, so we'll see if that works, or I have to do it at a different time. I guess the other question some of you might be having, I probably should have started with this, is what should you call me? People don't always know what to call their professors. There was a professor I worked with as an undergrad who he had a rule that said you can call me whatever you want as long as you would be willing to introduce me to your parents that way. So I like that rule. So I don't really care what you call me as long as it's not vulgar, basically, which is hard with my last name, I realize. But we will. So I'm not picky about what you call me. That said, a little bit of advice for people who are mostly pretty early on in college. Some professors do care, and they much prefer to be called either doctor or professor. If you call them Mr. or Mrs., that often causes anger for whatever reason. I'm not that type of person, but calling your professors doctor or professor whatever is probably your best bet to get in the habit of, but I don't really care. Okay, any questions about the syllabus before I move on? Okay, the last thing I'll do before starting the course material is my little attempt at a motivational speech, which is what's the secret to success in Chem 1331? Students ask some variation of this question all the time. Well, this course has a reputation of being difficult, and they want to know, well, how do I do well? What's the secret? And there's really not a secret to it. And the thing you have to realize is that there are a lot of resources available to you, and really what your job is to find out which combination of those resources is going to put you in the best position to succeed. It's different for everybody. Not everybody is going to find all the resources to be helpful, and part of the challenge of being a college student in general is figuring out the way that you learn best. But the resources are certainly there for you, and whatever you decide is the best way for you to proceed with the material, I urge you to do it on a weekly basis, because everything we cover builds on itself. So if you fall behind one week, it's going to really make it even more difficult to catch up next week, and so on. So the available resources, just to give you an idea of what they are, the textbook, as I mentioned, is not required, but is very helpful for a lot of people. The Blackboard assignments, we give you multiple attempts in all of those, so use those, because as I've already mentioned multiple times, the homework questions are very similar to the exam questions in a lot of ways. Another thing that I'll do, which students didn't use this a whole lot, but is still very helpful, I think, for me, is the Blackboard forums. So a lot of students, if they don't want to come to office hours, or they prefer, to send in their questions in writing, they'll email me questions, and that's fine. But what I'll usually do, or what I encourage you to do yourself before emailing me, is to post it to the Blackboard forum. There's a discussion board on Blackboard, I think it's called. Post your homework questions there. I'll answer it there, and that way all the other students can see it, and I don't end up answering the same question many, many times. So Blackboard forums is a good way to do sort of written homework help if you're not able to come to office hours, or you prefer that format. I'll do all the review videos like I mentioned, as well as the lecture videos this semester. There will be practice exams every time we have an exam. Now, the department is sort of cracking down on these practice exams because people were using them to harvest exam questions. So the practice exam this time is going to only be one attempt only. And it's only going to be one set of questions for all of you, so you all have the same practice exam. And that's going to sort of limit you from harvesting those questions, I guess. It's not a fear that I really have, but it's one that the department decided was best. So they only have one attempt on the practice exam, but it will be there, and it will be very similar to the real exam nonetheless. And it's definitely good to do that towards the end of your exam review. Now, there are some outside resources that you can use. The Department of Chemistry has a chemistry help room in 220 Fleming, so the second floor of the Fleming building. And I think they're Monday through Friday, 8 to 5 is what the posted hours are. So that's just walk-in chemistry help whenever you want to go there. And so the people that staff that are typically upper-class students who took this course before and did very well in it themselves. And that's, like I said, walk-in. There's also tutoring available through LSS, although as a department, we don't have as much oversight over that, so I don't have any way to vouch for the quality of that, but I know some students have used that and found it helpful in the past. I encourage you to come to my office hours. I'm always there to answer questions and help you get through whatever parts of the material you're having trouble with. So coming to office hours, set up appointments. And like I've already said at the beginning of this, it's your job, of course with my help, to figure out which combination of resources work best. There's no way you're going to have enough time to do every single thing on here all the time, but you need to figure out which are most helpful for you, and I'll certainly try to help you come to that conclusion. All right, so with that, we will move on to start the textbook material. Yes? No, so the question was, are practice exams extra credit? And they're not for any credit at all. So the practice exams, just like the practice homework assignments, you're welcome to do them, but they're not going to count towards your grade. Your results will be stored in Blackboard, so I believe you should be able to go back and review those results, but it will not be part of your grade book. Okay, so what we're going to do is we're going to jump right into Chapter 1. All right, so there is a review chapter in your book, and I covered that last year and then immediately fell behind, so I'm not going to cover the review chapter this time. That's totally up to you. Most of that material is on the PA exam, so it's things like unit conversions and significant figures, stuff like that. So definitely review that if you're a little bit fuzzy on it. Come to me with any questions you have. And there is a review homework assignment in Blackboard, which also does not count towards your grade, but it covers that part of the textbook. But I won't be going over that in lecture. We're going to jump right into Chapter 1 to make sure we don't fall behind, because we do have to get off to a running start. So today we're going to sort of talk a little bit about the history of chemistry. Not my favorite lecture to give, but an important one nonetheless. So to really understand where chemistry comes from, we have to understand what's called the scientific method. So you'll presumably hear more about this in your lab course. But the idea here is that everything we're going to learn in this course, all these things that we take as being facts, were learned through the scientific method. Okay, so nobody was born with an innate knowledge of chemistry and how atoms and molecules work. They had to figure that out through deduction and through the scientific method and doing careful experimentation. So there's basically 3 steps to the scientific method. You may see it divided up in different ways depending on the sources you look at. But the way I think about it is there's really 3 things that go on here. So the first thing is an observation. An observation is something you sense or measure. Qualitative or quantitative. So qualitative is something that doesn't really have any sort of measurable parameter associated with it. So if you said, the carpet in this room is yellow, or the chairs are red, or something like that, or the temperature, the weather is rainy today, things like that are not quantifiable are called qualitative measurements or qualitative observations. And then quantitative is something that has a number associated with it, such as, Professor Teets is 5 feet 9 inches tall, or the classroom is 23 degrees Celsius, something like that has a numerical value. So that's a quantitative observation. So both of those are valid and important parts of learning science. There's not one that's necessarily superior over the other. And so let's take an example that you're probably all familiar with, which is which is gravitation. We all know how gravity works, at least in some sense. So an observation, which if you believe the folklore, I don't know if this is actually true, would be, an apple fell on my head. That's the observation, right? So something happened. You noticed something happening, you observed it, and then you have to formulate a potential explanation for this. So you make a series of observations, or even just one observation, and then your hypothesis is going to be a possible explanation for that observation. So why did that happen? A possible explanation. And a hypothesis sometimes is referred to as an educated guess. It's a little bit more rigorous than that, but it's usually based on limited or flawed information. So it's not based on a whole series of observations. It's just sort of a possible explanation for why something happened. So it's based on limited or flawed information. So as an example, going back to gravitation, maybe Isaac Newton said, well, an apple fell on my head, and it's because the tree threw it at me. That's why. That's my hypothesis, that the tree threw the apple at me. Now, of course, that's a ridiculous one, but it's a hypothesis for why the apple fell on my head. But then if you want to really know if your hypothesis is valid or not, you do a bunch of experiments. So an experiment is, carefully designed to test your hypothesis. All right, so then what Isaac Newton would do, instead of just sitting under an apple tree waiting for the next one to fall, is he would go sit under other fruit trees. He would take an apple and drop it off a ledge and find, it still fell on my head, so it wasn't, doesn't have to be thrown by a tree. Or he would see that, if he put something else in the tree, it would still fall on him. So a bunch of, ways to test a hypothesis to see is this true or not. And, very often your hypothesis is flawed because it's based on limited information. But you do these experiments over and over again, and then it's sort of a cyclical process. So your experiment is a series of observations. So you design an experiment, collect more observations, and then from that, you're going to refine your hypothesis because you're going to eliminate certain possibilities, and you're going to design more experiments to test that, and so on. And the process goes on and on and on. So once you do this enough times, this whole scientific method, then we have some things that come out of this which are called laws and theories, and we're going to learn some of the early laws and theories in chemistry very early on in this course. So the two things that then come out of this scientific method are laws, which is what happens. So this has no real explanation associated with it. It's just a statement of fact. So in the example of gravitation, as Isaac Newton did more and more careful experiments, he learned that there's that, the inverse square law, which is the force of attraction for gravitation is depend on the inverse square of the radius. And so that's often a law is expressed in terms of a relationship or an equation, which says what happens in any given situation. So, so the law of gravity states that, if you drop an apple from this high, every single time it's going to hit the floor with this velocity. So it has these very predictable relationships that are come out of that, but it just tells you what happens, not why it happens. And the theory is sort of telling you why it happens. So a law is a repeatable, predictable observation, and then a theory is an explanation for why the for why the law behaves the way it does, basically. Now, one of the limitations of early gravitation was that they didn't have a really good theory for why it happened, but that's when, later on Einstein came along and had his theory of relativity, which really brought everything together. So very often, we have laws that are seemingly true, but the theory that explains those laws gets refined and refined and refined as we have more sophisticated ways of measuring the systems that we're interested in. So that's kind of how chemistry evolved. It started with some very simple ideas and some very simple laws that people could come up with, but then the explanations for those laws came about gradually over time as people got more and more complex ideas about how chemistry worked. So we're not going to really use the scientific method in this course because it's a lecture course, not a laboratory course, but it is important to understand it as a backdrop for a lot of things that we're going to learn. So what we are going to learn in this course, this is obviously a chemistry course, and that's the study of matter. So matter is anything that has mass. So basically you can think of it as, all the stuff that makes up our world or our universe is matter. And we're going to learn about a few different categories of matter. And there's really two major classifications of matter, both of which we're going to talk about in this course. Okay? So the first is going to be mixtures. Now we're actually probably not going to spend as much time on mixtures in this course. You'll see it a lot in chemistry too. We'll do a little bit with it in this course. But the point is that a mixture has variable composition. All right, and we'll get into more of what that means later on. And then if you have matter that has constant composition, that's going to be called a pure substance. Okay, so there's pure substances and there's mixtures, and we're going to talk about both of these in this course. We'll probably spend more time on pure substances. So pure substances, as we'll learn later on, are things like elements and compounds. And as a very simple example of the difference between a pure substance and a mixture, a pure substance is water. And no matter how much water you have, you guys all know that the formula is H2O. But then you can have a mixture, which would be, let's say, salt dissolved in water. And that mixture has variable composition because we could dissolve 1 teaspoon of salt in a glass of water. We can dissolve 2, 3, 4, and so on. So that mixture is going to have variable composition. It's going to have 2 components to it, 2 distinct components that are mixed together in various ratios. Now, within each category of matter, mixtures and pure substances, there are some subcategories that we'll also talk about as well. So within mixtures, we have what are called homogeneous and heterogeneous mixtures. Okay, we're going to spend most of the course, most of the stuff that we know is going to be a homogeneous or single phase mixture. And so what it means to be a single phase mixture is that it has multiple components, but you can't individually see the 2 components. So for example, salt dissolved in water still looks a lot like water. You can't tell that there's salt in it just by looking at it. So when you have a homogeneous mixture, you can't see the 2 phases or the more than 2 phases that mix it up. Now a heterogeneous mixture has visibly distinguishable parts. Sorry. Okay, so if you were to take sand and put it in water, we know that sand doesn't dissolve in water. You'd have water and sand on the bottom. That's going to be a heterogeneous mixture. You can still see the 2 components that make up the mixture. So that's what we mean by heterogeneous. We're not going to really talk much about heterogeneous mixtures because there's not much you can say about them in terms of a general chemistry standpoint. All right, and then pure substances also have 2 categories, or 2 main categories, which we're going to start with in this course: elements and compounds. All right, so elements are pure substances that can't be broken down any further. All right, so they're the simplest forms of matter available to us. They cannot be broken down into anything simpler. And then compounds are going to be chemical combinations of elements. So they're going to involve some sort of bonding interaction between the elements, things we'll learn a lot about in this course. So that's what we call a compound. And then really the whole study of chemistry is studying how elements and compounds convert between each other. So how do we, convert mixtures of elements into compounds? What are the forces that hold the elements together in compounds, and so on. So that's really what chemistry is all about, is this idea here of interconverting elements and compounds. So those are the basic classifications of matter, and we're going to talk about all of these in this course at some level. Now, the other way to classify matter is to look at it at a microscopic level. So this is what we call an atoms first approach to chemistry. So we're going to really look at things at the atom and molecule level first. So I don't want to go into a lot of details on this right now because we're going to hash these over and over again early on in the course. But an element, as I said, is the simplest form of matter, and it can't be broken down further. So what that means is that an element consists of only one type of particle, or as we call them, atoms. So an element could be just single atoms all collected together, or it could be 2 atoms bonded to each other, but only one of that type of atom. A compound is another type of pure substance, as we talked about on the last slide, and a compound is going to have 2 elements, as we said, chemically bonded to each other, 2 or more elements. So here I'm only showing binary compounds that have 2 elements, but they can have elements combined in different ratios. So here is 1 pink and 1 blue. Here is 1 pink and 4 black ones. So there's different ratios of elements that combine to make compounds. But again, if you have a pure substance that's a compound, there's only one type of particle that makes it up, what we call a molecule. And then if you have a mixture, you're going to have 2 different things mixed together. So you can have a mixture of elements. So this first one here would be a mixture of elements. Where each of the individual components is either just a single red particle or a single blue particle, meaning it can't be broken down further. So there are 2 elements. This one is a mixture of compounds because it has 2 different types of molecules mixed together. All right, so there'll probably be some questions like this on the early homework assignments, looking at microscopic views of atoms and molecules and classifying them as, mixtures of elements, mixtures of compounds, pure elements, pure compounds, and so on. So this is just a few examples of that, but we'll get a lot more details as we go along. All right, so we're going to now talk about some early chemical history, sort of the origins of the science that we're learning in this course. So the first people to really think about matter in any real way were the Greeks, the ancient Greeks. So they observed substances changing into other substances. Obviously, we're very familiar with a lot of things in daily life that involve those processes, like rusting and things of that sort. So the Greeks tried to explain this, but they had no knowledge of the scientific method. So they were kind of, in some sense, running around like chickens with their heads cut off. So they, the scientific method hadn't really developed yet. So they were just kind of aimlessly making observations and trying to explain things somewhat randomly. The Greeks proposed 4 fundamental substances. We now know, of course, this is wrong. But this was one of their contributions to the early ideas of chemistry. So they're earth, fire, air, and water. I might be dating myself a little bit if I make a Captain Planet reference here, but those are the 4. Nobody knows who Captain Planet is? My goodness, I'm getting old. All right, so Captain Planet was a superhero that used earth, fire, wind, and water to make his superhero powers or whatever. But anyway, that was the Greeks that came up with that. But that's, of course, not an accurate description of matter. And they were the first ones to actually propose atoms as fundamental particles, but they really had no evidence to support this claim, and they had no insight into the structure of atoms or how they behave or anything like that. They just said, well, there's probably got to be some fundamental particles out there that make everything up, some building block, and they called them atoms. That's the Greek word atomos, which is what atoms comes from. So the Greeks came up with that idea, but like I said, they had no way to explain it or no way to rationalize it. Later on, for a long period of history, we had the alchemists, and the alchemists practiced what is called pseudoscience. So they were trying to do some real science in some sense, but it was very much based on superstition, and again, not a very good application of the scientific method. So they were mixing things together. They were making observations, but they weren't really following the scientific method. And this alchemy persisted for a span of almost 2,000 years. So it really, a long period of our history involved studies of alchemy. And what they were really obsessed with is changing base metals, things like lead, into gold. Okay, so back then and today, gold was a status symbol of wealth. And so these alchemists wanted to try to take other things that were cheap and useless, like lead, and turn them into gold. Now we know today that you can't really do that, especially not with the ways that they were trying to do it. So again, this was very much rooted in superstition and folklore, the idea that there has to be a way to do this. And if they had done more careful studies, they would quickly find, well, no, there's not a way to do this. But they were obsessed by that idea, and so that's why we sort of called it pseudoscience. They made some very important observations about substances that we still use today, but it was not a very scientific approach and not one that yielded really any insight into the chemistry. The first chemist was named Robert Boyle. So I guess the Greeks were very happy in their blissful ignorance, and then as people came to understand things more, they became depressed for whatever reason. But these, I actually think, should be the opposite, because these were the first people to really help us understand how matter behaves. So Robert Boyle is widely regarded as the first chemist, and so what we mean is he's really the first person to carefully apply the scientific method to studying chemical problems. And his big contribution, which we'll learn a lot more about later on, are quantitative measurements. I didn't spell that word right. It'll erase eventually. Come on. Quantitative, there we go, measurements on gases. So we will learn about Boyle's law later on. That's his big contribution. And so he was really the first person to make these types of quantitative observations about chemical systems, something that the Greeks and the alchemists never really did. And he also proposed the concept of elements. So the first person to really, say that there has to be these very fundamental substances that can't be broken down further, that was also one of Boyle's contributions, although that was a topic that was debated and refined much over the future years. And then another very important player that you should be aware of is Joseph Priestley. He was credited with the discovery of oxygen, which of course is a very important element that we wouldn't be alive without. And he studied its chemistry. But what his real contribution was, Robert Boyle was studying sort of physical properties of gases. And as we'll learn things about, if you compress a gas, how does this pressure and volume change? But Priestley was really one of the first, or the first, to study chemical reactions. So he carefully studied how substances convert in between each other and applied the scientific method to really understanding chemical reactions a lot better. All right. So these early scientists then, through a lot of careful studies, came up with 3 fundamental laws about matter that are called the mass laws, and then 1 theory to describe them. So this is what we're going to close with today. I don't have time to probably load up this YouTube video, so I'll have this link for you. We're not done yet. I'm just telling you this is the last thing we're doing, but we're not actually done. So the mass laws were some of the earliest fundamental laws of chemistry to come about, and if you think about it, measuring the mass of a substance is quite possibly the easiest thing you can do. One of the most least sophisticated measurements you can make is just how much does something weigh. So a lot of these early scientists, they studied chemical reactions and they measured masses that were involved in chemical reactions, and they came up with some fundamental laws about how matter behaves based on the masses of the substances that they studied. So mass conservation was formulated by Antoine Lavoisier, which, as you might imagine, is from France. And basically the statement of the law of conservation of mass is that any chemical reaction the mass of what you start with, which we call the reactants, is equal to the mass of what forms during the reaction, which we call the products. All right, so a chemical reaction is involves converting 2 substances into different substances, or even one substance into a different substance, and the mass that you start with is always equal to the mass of what you end up with. Another way of stating the law of conservation of mass is that matter is neither created nor destroyed during a chemical reaction. All right, so you put matter into a chemical reaction, and that matter is going to come out on the other side as something different, but you're not going to lose or gain any new matter. Okay, so that was the law of mass conservation. That one may seem obvious to us, but at the time it was very important. And then we'll do one more mass law before we close up today. So the second law is called the law of definite composition, and this one was formulated by Joseph Proust. Or perhaps, I think that's the right pronunciation, it might be Proust. Anyway, so the law of definite composition is a law about chemical compounds, specifically. So a given compound is always going to contain the same proportion of elements by mass, regardless of the source. All right, so what this means is that if you take a sample of salt, which we know is sodium chloride, if I go in the lab and I make sodium chloride by mixing sodium and chlorine together, or if you go out to a salt mine somewhere and collect sodium chloride from a salt mine, those 2 samples of sodium chloride are going to have the exact same mass composition of sodium and chlorine. So for a pure substance, it doesn't matter how you prepare it, the mass ratio of the elements is going to be the same. So this is what gives us what's called a mass percent. So as an example of this, if we have 44 grams of carbon dioxide, so you're all familiar with carbon dioxide as one of the gases you exhale and that plants use to produce sugar. So 44 grams of carbon dioxide is going to contain 12 grams of carbon and 32 grams of oxygen. And again, it doesn't matter if you're talking about carbon dioxide that you exhale versus carbon dioxide that forms when you burn something. No matter what, if you measure a sample of 44 grams of carbon dioxide, it's going to have 12 grams of carbon, 32 grams of oxygen. Now, a more convenient way to express this. This is hanging up on me. It's telling me it's time to quit. A more convenient way to express this is with a mass percent. So instead of saying, mass out of 44 grams, let's do mass out of 100. So the mass percent for any in a compound is going to be the mass of a certain element, which we'll call X, divided by the mass of the compound, and for a percent you always multiply by 100. So this is going to tell you how many grams of this element are in 100 grams of the compound. So for carbon dioxide, in general, this would be the mass fraction times 100. So if we ask for the mass fraction, it's just the ratio of the element to the mass of the compound. So for carbon dioxide, if you want to find the mass percent of oxygen, we know that our sample of carbon dioxide has 32 grams of oxygen for every 44 grams of carbon dioxide. So it's the mass of oxygen divided by the mass of the compound. We multiply by 100 to make it into a percent, and that gives us 73%. So carbon dioxide is 73% oxygen by mass. Another way of thinking about that is if you have 100 grams of carbon dioxide, 73 grams are oxygen. And these mass percents are the way that we're going to typically express mass compositions for compounds. All right, I'll wrap up with that. We'll get to the other stuff next time, and I'll see you on Friday.